Okay, now we're going to learn a theorem today that you could actually probably live without knowing, because you could use triangle sum and a straight angle to find it, but we're going to learn the triangle exterior angles theorem. Sometimes it is useful when you have x's and y's. So first vocabulary word is the exterior angle of a polygon, and it is the angle formed by a side and an extension of an adjacent side. Okay, so for example, this is an exterior angle. We see the triangle, right? If not, let's highlight it. This angle, angle 12, is formed by a side of the figure, this side, and it's formed by an extension of this side. So when it says an extension of the adjacent side, that would be extending this one out. Okay. Remote interior angles. Now, interior angles are inside, but when you call them remote interior angles, those are going to be the two non-adjacent. Remember, adjacent means next to or beside. So non-adjacent interior angles corresponding to that exterior angle. So for example, the remote interior would not be 9. That's the adjacent, and we want non-adjacent. So this would be a remote interior, and this would be a remote interior. Okay, and think of like a remote desert island is like far, far away. The remote interior angles are going to be further away from the exterior angles. Okay, so looking at this picture over here, we can see that angle 1 would be our exterior angle because it is formed by a side of the triangle and an extension. What would be the remote interiors? Joseph? 3 and 4. Okay, now there's lots of other pairs in the other picture that we could pick up with. So for example, let me just grab my eraser real quick. Could someone identify another exterior angle and then the two remote interior angles that would be paired up with it? Marquise? Angle 3 is an exterior angle, good. What would the two remote interiors in regards to that one be? 9 and 5. Now, is 2 considered an exterior angle by the definition? Look at angle 2. Is that considered an exterior angle? Is it formed by a side of the triangle and an extension of the side? No. So this would be exterior, this would be exterior. This is not anything. You could say these are vertical, okay? But that would not be an exterior angle because it's not formed by a side of the shape. It's formed by two extensions, which doesn't satisfy that definition. All right, so our example number 1, find the measure of angle 1 using triangle sum. Luke? Yes.
So would that mean that 6 would be exterior?
Yes, 6 would be, let's do another example then. Yes, 6 would be exterior because it is formed by a side and an extension of the side. What would the two remote interior be regarding?
It'd be
4 and 9. You got it.
So like the remote interiors change on which exterior?
Correct. Correct. They will change every time you change the exterior. So if we were saying 8 was the exterior, that actually would still be those two. But whenever we switch over here, 10, then it would be 4 and 5. 12, then it would be 4 and 5, and so on. All right, example 1. Find the measure of angle 1 using triangle sum. So notice angle 1 is out here. So the first thing you have to do is find out how big that angle is. How big would that angle have to be? Using triangle. No, probably not. No, definitely not. 130. Triangle sum tells me that 20 plus 30 plus the missing angle has to equal 180. So that's 50, and we get that that is 130. Not drawn to scale at all. So then, what would the measure of angle 1 have to be? Justin? 50. Do you notice a shortcut to find the measure of angle 1? Justin?
Yeah, 20, 30, 50.
Perfect. Instead of having to do triangle sum, and then using a linear pair to subtract from 180, which you can do that, you can notice that the exterior angle is equal to the sum of the two remote interior angles. So that's exactly what this theorem says. The triangle exterior angle theorem says that the measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So in our example here, the exterior angle would be angle 1. So we'll say that the measure of angle 1 is equal to our two remote interiors, which I usually label Ri, would be 2 and 3. So this measure of angle 1 has to be equal to the measure of angle 2 plus the measure of angle 3. So this is a shortcut for triangle sum, so that you don't have to do triangle sum to get this and a linear pair, like a 2-step problem comes down to a 1-step problem. Sometimes you'll see me write the formula exterior equals remote interior plus remote interior as like a formula that's representing this theorem. Okay. So on the back we have a couple examples, and we will see some that have variables. Find the measure of angle 1. So most of you will just say measure of angle 1 is 70 because you understand it, but if you don't, you'd want to label this is our exterior, this is our remote interior up here, and our remote interior down there. So we can use the triangle exterior angle theorem to tell us that the exterior angle equals the sum of the two remote interiors. So 40 plus 30 tells me that angle 1 is 70. Now again, if you wanted to, you could do triangle sum to find out this is 110, subtract from 180 and get 70, but obviously this is much shorter. Now the next one's a little different. Why? It's different, Joseph?
Because the exterior and one interior.
Good. It gives us the exterior angle. It gives us one remote interior. It wants us to find the other remote interior. So you are still going to use the theorem, which says exterior equals remote interior plus remote interior, but you're going to have to solve it. So we'll plug in 113 for the exterior. One of our remote interiors is 70. The other remote interior we don't know. So I'm just going to put like x, or measure of angle 2. So what would our answer be? Preston? 43. We have to undo addition with subtraction. Do you have to show this work? No. For those of you that are understanding it, just subtract the exterior minus the remote interior. But for those of you that like more of an algebraic method, that's the best way to do it. All right, now we have exteriors and interiors. I don't care how you do this. So even though I have directions here, you don't have to follow them. I have used the exterior angle theorem, then use a straight angle. You could use triangle sum and the exterior angle theorem. Or you could use the exterior angle theorem and triangle sum. So go ahead and find x and y in that picture, and then we will have a little puzzle problem down here as our next one. All right, who can tell me what they got for either variable? Doesn't matter which one. Maddie? X equals 74, very good. If you wanted to find x first, you would go ahead and do triangle sum. 52 plus 54 plus x equals 180. Or if you found y first, then you can just subtract from 180. And so for y, we should be getting 106. And that could be using the remote interior angles, summing them together to get your 106. All right, last one for this section of notes, we have a little puzzle problem asking us to find some angle measurements. Now they only ask us for the measure of angle 1, 2, and 3. We may need to find more angles in the picture to be able to find out what 1, 2, and 3 are. So you want to look for straight angles. You want to look for vertical angles. Sometimes you'll also have parallel lines in these problems. We don't in this case, but if you have parallel lines, you want to look at alternate interior, corresponding, all that kind of stuff. So who thinks they could find another angle measurement based on one of the numbers we're given? Brett?
3 should be 60.
Yes. We should see that these right here form a linear pair or a straight angle. Straight angles are 180. 180 minus 120 is 60. So we do have one of those. Marquise?
Angle 1 is 50.
Angle 1 is 50. How'd you get that?
Because they both have set the interior frame to add up to
Oh.
120.
Good. So he used that this is an exterior angle, and it has to equal the sum of the two remote interior angles. You don't have to do it this way. This is using the theorem that we learned today, though. And then we could subtract 70 on both sides. Let me show you another way you could get that. What type of angles are these? What do we know about vertical angles? They're always congruent. So once you get this one, you could then do triangle sum instead and get 50. Okay. And then, of course, since this is 50, vertical angles here, again, this one also has to be 50. Since my flip chart's not working, I don't know what the diagram looks like. And I don't remember because it's not on my paper. So I was supposed to have a diagram, and for the closure we were going to explain what was wrong with the diagram.
That diagram.
No, it's not. What's wrong with that diagram then?
2 and 3 are the same side exterior angles and they're not congruent.
No. They are same side exterior, but we don't know they're parallel. So they wouldn't be, they wouldn't follow any of our theorems or postulates. So that was a good idea. I think it looked like this. And I think it was like, we would say, what's wrong with this diagram? 2 things, Jeremiah? Okay, the remote interiors don't add up to be the exterior. Also, if you were to find this angle, this would not add up to be triangle sum. So it violates either triangle sum theorem or the exterior angle theorem. So I think what my picture looks like. All right, we are going to start section 3.5. We're not going to do a lot of it. We'll probably just do, I think, the first page should be fine. And then maybe our chart. So section 3.5, we're going to start talking about polygons. All we're going to do today is classify them. So most of you know pentagon, octagon. Some of you won't know some of the bigger terms like a dodecagon, but we will talk about that. So a polygon is a closed plane figure with at least 3 sides. So triangle is the smallest one that you could have that's closed. And they are segments. The sides will intersect only at their endpoints. Okay? And it says no adjacent sides are collinear, which means like A and B can't be in line with A and E because then that would be one side instead of 2 distinct sides. It has to not form a straight line. So this one is a polygon because it's closed. So this is a polygon. The next one, we can say that it's not a polygon. Why? What part of the definition? Yes. It's not closed. And then how about the last one? Is that a polygon? Joseph? No, it's actually 2 different polygons. It's not one polygon though. And that's because these sides intersect at 2 points instead of at, they're supposed to only intersect at the vertices. Okay, so I guess we should say sides intersect. But technically that would be 2 separate polygons that just happen to touch. All right, you can classify polygons just like we classified a triangle as, an isosceles, right, triangle. You can classify a polygon as being concave or convex. Now concave, think of caving in on yourself. It will be taking one of the sides and kind of folding it inward, going into the shape. Okay, so it will have a diagonal when you draw diagonals, which you can see the diagonals are drawn a little bit more clearly on this one. But one of the diagonals will have points that are outside the polygon. When I look at the pictures, and you'll see tomorrow's homework, we'll have this on there. I would just look and see, does it look like the polygon has been folded inward? That's a little easier for a visual. Okay, a convex polygon, when you draw the diagonals, which is connecting any of the vertices, all of the diagonals will fall inside. Okay, so no diagonal will have points outside. Rather, they'll all be inside of the shape. You know. And then we also have, just like we have with triangles, we have equilateral polygons, which will have all sides congruent. So if it's an equilateral pentagon, all 5 sides are congruent. Equiangular, of course, has all angles being congruent. And then this is a really important vocab, a regular polygon. So if I tell you it's a regular pentagon or a regular hexagon, that is going to indicate that if it's regular, all sides and angles are congruent. All sides and angles are congruent. Naming polygons. So when you name a polygon, you're going to use the vertices. You can pick any vertex to start, and then you're going to list the remaining vertices by either going clockwise or counterclockwise in order. So the name of this polygon would be polygon, I'll just start with B, E, D, H, K, M, J. You kind of saw this with triangles yesterday with just the 3 letters. Then they want us to identify the vertices, the sides, and the angles. I'm not going to identify the vertices. We can see there. If you want to name the sides, they're actually all segments. We would say segment BD is one side, segment DH, segment HK, segment KM, MJ, or G, excuse me, and GB. So again, I would go clockwise or counterclockwise so you don't forget a side. And then the angles you can name using the vertex because there's only one angle that touches B. So that would be angle B, angle D, angle H, angle K. We can also classify a polygon by the number of sides, like I was talking about, a pentagon, a hexagon, etc. So I'm going to pass out this little chart. We're not going to do this whole thing today, but we'll just fill in the number of sides each polygon has.
So are you done with the packet?
I don't know. Don't put it away. Now, in the packet, we're going to fill this in. So you can also classify a polygon by the number of sides it has. So a 3-sided shape is going to be called a triangle. We'll go to the chart in a second. That's what the ... We're going to put C chart. If a polygon were to have 20 sides, there's not a name for a 20-sided polygon. So you would just call it a 20-sided polygon, okay? And we'll see that here. Let me go to the chart. I opened it up and it disappeared. Alright, so obviously a triangle will have 3 sides. A quadrilateral, 4. Pentagon, 5. You do need to memorize these if you don't already know them. Hexagon is 6. Most of you may not remember or have known that 7 is a heptagon, so I put a star next to that one. You probably want to memorize that one. Octagon is 8. Nonagon, I'll put a star next to that. Maybe you don't know that. Decagon, I feel like you do know. The 11-sided one, most people think I made that word up. I didn't. It's an undecagon, and that is 11 sides. The last one is a dodecagon. A dodecagon is our 12 sides, so I'm going to put a star next to that one too. Okay, an n-gon would have n sides. So you could say a 20-gon would be 20 sides, or a 30-gon would be 30 sides, if you have something bigger than 12. Okay? We're not going to fill in the rest of that because we need to learn the formulas, but we're going to wait till tomorrow on that. But again, you'll have to memorize those if you don't already know them. So I'd like to go back and have you guys just complete the classifying by sides while I pass out your homework. So let's just do this part. So see if you can classify the polygon by the number of sides it has, and also classify it as being concave or convex. All right, classifying this by the number of sides. How many sides does it have, and what would we call it? Marquise?
6.
6, which makes it a hexagon. Is this concave or convex? Joseph? Convex. Again, if you want, you can actually draw all the diagonals in and show that none of them go outside the shape, but also you can just look and see it doesn't look like it's caving in on its own. The next one has how many sides? Maddie? 8, so we call it an octagon. And would this be concave or convex? Yeah. Concave. Again, it looks like this side was kind of folded in. Luke, did you have your hand up for your structure? All right, that's it for today.